Hi again. In this video, I want to show you more details about the second half of the process of the hypothesis test. And just to remind you, here were our steps from a previous video. So we're going through these steps, writing the null and alternate hypotheses. We've talked about that in detail, but we'll still practice with 2 more full tests. And then we've done some simulating of the null world or the null hypothesis with a randomization distribution. And then we've seen what this p-value is and this how to get an image. And then we've compared the p-value with a significance level and stated the conclusion in context. But I want to explain more about C, D, and E. I want to break those down a little bit more, okay? So that's what this video is about. So p-value, significance level, and conclusion. So remember, in this whole process, we're setting up our randomization distribution, assuming the null hypothesis is true, okay? And we do have to have a given sample size because that affects the graph. Otherwise, we'd have a different, wider or narrower graph depending on the sample size, okay? And this null, it's sometimes called the null distribution. Let me write that down. That's also another word. It's another way it's referred to. Null distribution. This null distribution, this is like the accepted value, status quo, or no effect, okay? And then the p-value shows how strong our evidence is under this assumption, okay? So what exactly is a p-value? And p-value is one of the most misunderstood things. So if you watch outside videos, be careful because a lot of times they're actually explained wrong. So be careful about that. So the p-value is a probability. So it's p for probability. That's one thing to keep in mind. It's a probability. And we've seen it's how many samples we got. So it's calculated as a proportion in our simulation. Probability of getting a result at least as extreme as the observed result, which is also called our sample statistics. So this could be our p hat, or later we'll see it could be our x bar. Okay, and that's under the assumption that the null is true, okay? The smaller the p-value, the stronger the evidence against the null and for the claim. Okay, so we are actually looking for small. Smaller is better. And then we compare the p-value with the significance level. Okay, so I'm going to write smaller is better. That's evidence for the claim, or evidence against the null. You can say it either way. Okay, now remember how we compared, once we got our p-value, that was the chance of getting the result we got, or towards the tail. Then we compared that with alpha. And alpha, which is a Greek letter, it looks like kind of like a little fish, like I would draw a fish if I was drawing it a little wider like that. The most common significance level is 0.05, and that's the one we saw so far. So we say if there's less than a 5% chance of getting the observed result, then that is statistically significant. So remember, we use this 95% and 5% a lot in statistics. So we say if it's less than 5%, then that's pretty unlikely under the null. And then if that's the case, then it is statistically significant. Now, this is not the only significance level, so that's why it has its own symbol. If it's something life or death, then we don't want to use 0.05. 5% is not good enough, right? We might use a 1% or a 0.001% or something. So it depends on the context. Social science, we might use 10%. So look for, in your questions, look for whether it's given or not. If it's not given, then you're going to use the default of 0.05. Okay. Just bugging me that I didn't get my T crossed up there. Okay, so that's the significance level. We're going to look for, we might be given one in a question. If not, we're going to use 0.05. Okay, so we've seen that a little bit already. Okay, and then stating the conclusion. So let's start with if p-value is greater than or equal to alpha, and that's what we saw in the tire, choosing the tire test, it wasn't significant. So if the p-value is greater than alpha, or the p-value is large, that's another way to say it, then there's not enough evidence to suggest that the alternate is true. And that's because the result is fairly likely under the null, so it's likely to happen just due to chance or random variation. And it's not statistically significant. Okay. If the p-value is small, so I'm going to write large and small. If the p-value is small, remember, small is good in this case. At least if you're going for the claim anyways. If the p-value is small, we reject the null hypothesis. And we say there is evidence to suggest that the alternate is true. So it's unlikely that this result would occur under the null hypothesis, so it's unlikely to happen due to chance or random variation by itself. This is evidence for the claim, and so we say the result is statistically significant. Interesting, huh? Now you might be wondering about this wording here. We either fail to reject the null or we reject the null. Notice we don't accept the claim or fail to accept the claim. We're always talking about the null. So remember, we're setting this whole thing up based on the idea, the assumption that the null is true. So that's why in our conclusion we're dealing with the null. But then I've got some other more information down here. Why do we fail to reject or reject, right? It seems, I mentioned it's kind of like legalese. I feel like a lawyer in this section. You might be wondering why we don't accept the null. We can only fail to reject it. So sometimes you hear an analogy with our court system in the null and alternate hypotheses. So think about an example where you have a defendant and they're always presumed innocent until proven guilty, right? So the burden of proof lies with the alternate. So our null, in that case, the defendant is innocent. That's our null. And what the prosecutor has to prove, they have to show evidence that, that the person has committed this crime, is guilty. Okay, but the burden of proof is showing the evidence. Otherwise, we just go back to the null, right? So if they haven't shown the evidence, then we don't reject the null. If they have shown the evidence, we reject the null, and we say that they are guilty. Okay, so that's kind of what I wrote down here. Let's see if there's any different wording. If there is sufficient evidence, then the defendant may be proven guilty. In that case, we would reject the null hypothesis. Otherwise, we fail to reject the null and they're proven not guilty. It's impossible to prove that someone is innocent, right? You can't prove the null. You also really can't prove the alternate. That's why we just state the evidence. We say there's evidence for the alternate or there's not enough evidence for the alternate, okay? So it's impossible to prove that someone's innocent even though they very well may be. Okay, so I hope that helps understand some of those last steps that we're doing. And in the next video, we'll go through another complete example. So I'll see you there.